Okay, today we're going to divide a trinomial by a binomial. And I want us to, what does the word trinomial mean?
Like 3.
Yes, it has 3 terms. So we'll have something with 3 terms, and that'll be under the little division symbol, okay? And the binomial will only have 2 terms, and it'll be on the outside, okay? So it'll be on the outside, all right? Let's first review what division looked like when you were doing just numbers without letters, okay? And here's one. And so when we were doing this back when you were in elementary school, we looked and we didn't try to say what 21 does it go into 67. We went clear back to this first digit and we said 2 goes into 6, so we can kind of estimate. So 2 goes into 6 3 times. And since it's 21, it's not like 27 or something bigger than 5, so probably a 3 would be work. So what we did is we tried it. We said 3. Mm-hmm. And then we took, and we actually, you were doing the distributive property, you didn't realize it. You took the 3 times the 1, which was 3. And then you did the 3 times the 6, mm-hmm. which is, the 3 times the 2, which is 6. That is the distributive property, and you just didn't realize you were doing it. Then we subtract. So then there isn't anything there, and we have a 4, and we bring down the 2.
So then it'll be, 21 goes into 42 twice.
2 times. And we know it's going to be perfect because when we multiply the 2 times the 2, 1, it's a 2, and the 2 times the 4 is a 42, and it goes in nice 42 here with a 0 at the end, and we have
the 32.
The 32. And this is one of the factors, by the way. When you were dividing, you had the product right there. Mm-hmm. These 2 things multiplied together will equal this one. So the product was underneath, and you found one of the factors by doing this, okay? All right, now we're going to go to doing this with letters. We have a binomial. Notice there's 2 terms out there. And we have a trinomial in there. There's 3 terms, okay? We're going to find, we know one of the factors. We're going to try and find another factor up here at the top, okay?
Okay.
We go to the same idea. We look at the first term, and we say 2x multiplied by what gives me 6x squared?
Oh, 3.
3. And it's 3 what?
3x.
3x. And so we do the same thing we did before. We write it right above here, 3x. And then we do the distributive property.
So it'll become and then that'll be 9.
Yes, and it'll be 9x positive. And then we're going to do this times this here, which will become
6.
6x to the
squared.
And we subtract. Now this is the only part that I can see where it could give you a little troubles. We're going to subtract. And when we subtract, we have to subtract everything. We have to subtract this one and this one. Okay?
Okay.
All right. So I wrote it in a different color so that we would remember that you have to do that, just that, almost like we're distributing that negative is what we are doing.
Okay.
So here we have a negative x and we have a negative 9x. We don't have to. The nice thing about this one is you don't have to borrow it all. You just write it as a negative if
so
it
it'll
is
be negative 10x.
Mm-hmm. And then this one right here totally cancel out, right? Mm-hmm. And then when you bring down
minus 15.
All right. We erase and I call them the rainbows. We're going to erase those over here so we don't get confused. All right. Now, we go back and we say 2x multiplied by what gives me negative 10x?
5.
Yes. Negative or positive?
Negative.
Negative 5. Okay. All right. So I'm going to distribute that. That's going to become negative 15. This is going to become negative 10. And as you notice, when I'm going to be subtracting it, we'll be adding the opposite because we change it, and that'll cancel out, and we'll have a remainder of 0. This is the factor.
Oh,
all right? Okay. So it's the same thing we do with the division that you learned back in elementary school. I think it's nicer because there's no borrowing when we subtract. When you look at this, you just totally take it right as it is, and you don't have to. Most of the time, there's not very much estimating and going back if you didn't make it right.
Right.
Okay?
Okay.
So we're done.
Okay.